Hi all, in this video I would like to demo Google Cloud Dataflow Streaming Data Processing. So in our previous video we have seen how we can process batch data using Dataflow, right? So here are some prerequisites and assumption made for this demo as well. One should already have some good understanding of all these listed GCP services and also the basic understanding of Python programming. I will also go through each of these service on high level. Dataflow. Dataflow is a unified batch and streaming data processing service. By using this, we can process big data in parallel and distributed manner. Apache Beam SDK, it's a programming model to create pipelines, right, which can be run on different runners like Dataflow and other open source runners like Spark, Flink, etc. BigQuery, it's a petabyte scale enterprise data warehouse available on GCP platform. So data can be stored and analyzed using standard SQL. GCS is a object storage service available in the GCP. So you can store any kind of data like structured, unstructured or semi-structured. Cloud Shell. Cloud Shell is an interactive shell and run for Google Cloud Platform, right? It comes with some pre-built up instance softwares, right? You can interact with any other GCP services through CLI using Cloud Shell. PubSub is a global messaging service which works based on publisher and subscriber model and also allows services to communicate asynchronously. Cloud Scheduler is a fully managed grant app available in the GCP, right? You can schedule any job using our standard grant app, right? So then we'll go to our use case 2 where we will try to demo streaming data processing, right? So here is the use case. I would like to go through each and every step here, right? So just observe the reference architecture shown in the bottom of the slide, right? What we are trying to do is, so right now we don't have a devices or a sources which can generate streaming data, right? So to mimic or generate streaming data, I'm trying to leverage or use Cloud Scheduler in this use case, right? So Cloud Scheduler, as already explained, right? So it's a fully managed grant app. So what we are trying to do is we will try to basically schedule a job which will send a message, right, at every 1 minute interval, right? That's what I'm trying to do. In the first step, through this grant app scheduler job, we will receive a message at every 1 minute interval time. So that will be published to a PubSub topic, right, at every 1 minute interval. So from the PubSub topic, we'll try to read that message into our Dataflow pipeline, right? So here, once it is available into Dataflow pipeline, then we will try to perform certain transformation on top of each message, right? So here we are trying to perform some basic transformation. So I don't want to make it too much complex in this demo. Let us keep it simple. So I will try to explain what we are trying to do, right? What we are trying to do, right? So every 1 minute we'll receive a message from PubSub topic. So we'll try to append an arrival timestamp to each message, and also we'll try to append some numeric key for reference, right? So here we have to understand this streaming data processing, right? How it can be processed using Dataflow, right? Usually the standard practice is streaming data means continuously coming data. There won't be any basically what you say boundaries, right? It's unbounded data, right? It's continuously coming from the source. But to process it, somehow we need to divide it into some fixed windows kind of thing, right? So for that, what I've done is So I've divided this unbounded data into fixed windows based on every 2 minutes. What I'll do, for every 2 minutes I will read the messages, right? And then I'll append timestamp and also some numeric key. Then I'll try to write the data into BigQuery. So, right, in the reference architecture diagram, it's clearly mentioned at each and every step what we're trying to do. So I hope you understand it clearly. Yeah. Right. So now for every 2-minute window, we are going to have 2 messages, right? Because for every minute we are receiving a message, right? So then in 2 minutes window, we are going to have 2 messages with timestamp and numeric key appended, right? So this is the use case, and I also like to explain the pipeline command which we are going to submit it through Cloud Shell, right? And then I will also walk to the code on high level, right? So here, if you see the pipeline command, right? So as discussed in the batch data processing, here also almost same, right? So stream data flow is a Python program or pipeline where our code is written, right? The project where you are trying to submit the data flow streaming job, and also region. So this is one of the important parameter, because based on this only your data flow worker will be get spinned up and your workload will be running in this region, right? Here input topic, in case of batch, we will try to read data from GCS or other sources, but in streaming case here, right, we are trying to read data from PubSub topic. That's where, if you see, stream data flow is a topic created for this use case. We are trying to read messages, okay, from the stream data flow topic. I already discussed PubSub works in a publisher and subscriber model. In this case, Cloud Scheduler is a publisher where it publishes messages at every 1 minute interval, and Dataflow is acting as a subscriber. It extracts or receives the message from PubSub topic at every 1 minute interval, right? Then it group that messages based on the fixed window every 2 minutes by appending timestamp and a numeric key. Then it will write the data into BigQuery, right? Now the output path is defaulted into some GCS bucket, okay, and the runner is Dataflow runner, and the temp location is this. So temp location is used by the Dataflow job to write some its internal files, right? Now if you see, there are two important input arguments like window size and number of shots. So window size, I already told, I'm passing parameter as a 2. So inside my pipeline code, right? So what I'm doing, I'm multiplying this particular numeric number with the number of seconds, 2 into 60, right? So then it will be like 120 seconds. It's a 2-minute window. The number of shots is the concept of shot is like this, okay, right? So if you take, because our data will be processed in distributed manner, right? For example, let's say based on our workload, there are some 2 workloads have been spinned up, and then our workload has to be distributed across these 2 workers, right? Then what will happen, right? Based on the number of shards, right, our entire workload or data will be divided into equal chunks, 2 equal chunks, and it will be distributed across to these 2 workers, and it will be, once the process is done, it will be collected by the data flow master, and then it will be submitted back to its calling environment, right? This is how a parallel processing will be it will be done, right? Yeah, let's move on to the code, right? Then we'll see the demo, right? Okay, here is the code for this stream data processing. In the first step, right? So here it is the import statement, right? Whatever the modules or packages are being used as part of this pipe. So the first thing is group by message by fixed window. This is one class. So what we are trying to do is here is, right? So we are trying to perform multiple transformation on single P collection. So P collection is a distributed data storage in Apache Beam pipeline, right? It's a distributed data set where you can store any amount of data. So that can be processed parallel and distributed manner, right? So if we have to perform multiple transformation on top of a P collection, then we are going to use this type of functionality, right? So here what we are trying to do, if you see, we are trying to do, right? So we are using Pardot as well, parallel to, where we are trying to add timestamps to each and every message, right? And also once we add the timestamps, we will also try to add numeric key each and every message. So here we are trying to perform two transformation. One is adding timestamp and also one is adding numeric, right? And then we are grouping based on the window size. Okay, so this is the Purdue parallel to. So this is basically uh, it's getting called inside this composite transformation class. Okay, then we have some simple method to parse data. So finally what we are trying to do, we are trying to write this data into BigQuery, right? I already discussed, in order to write some data into BigQuery, first of all it should be readable by the BigQuery. It should be either in dictionary format or in JSON format. So we are trying to convert it to dictionary format in this function, right? Whatever the data passed to this function, it will be converted into dictionary format or BigQuery row format, right? So then we have a run method. It's an entry point to the actual pipeline. If you see, right, you have to observe this particular parameter. Streaming is true. So don't specify this particular parameter. This whole pipeline will be considered as a batch. Alright. So since it is defined as streaming as true, then it will be considered as a streaming. Streaming means this pipeline is going to run forever till you cancel it or drain this pipeline. Right. So here we have the pipeline and series of transformation that we have been performing, right, on top of this data, streaming data, right? Reading the information message from PubSub topic and then window into, that's where we are trying to append timestamps and also numeric numbers to each message, and we are grouping, right? And then we are converting the data into BigQuery readable format. Then we are writing the data into BigQuery, right? So here we have the main method, and then since we are reading input arguments from the command line, we have to define that, right? Each and every parameter. We have to default each and every parameter some value. That's what we are doing here, right? Yeah, I hope you understand this code and high level. Let's move on to the demo. Okay, so let me submit my streaming pipeline. I just submitted this pipeline, right? There is some error. Okay, right. uh, yeah, now it is running. sometimes what will happen, right? Because since I copied the command from the text editor, sometimes it won't recognize that indentation and everything else. I just authorize it. Now it is running. Okay. So it will take some time to spin up Dataflow workers. So meanwhile, we'll go to the Dataflow console, right? We'll see what is happening. Let us refresh. You see the streaming job has already been submitted. Now it is in running state. Right. Let us see. As per our architecture, so messages has to come through our Google Cloud scheduler. Let us see if that scheduler is on and running. Right now it is in past state. Let me resume it so that it will publish messages at every 1 minute time interval. Okay. Yeah. Now it's resumed. Now it will take some time, right, to propagate these messages to PubSub topic, and then from PubSub topic to Dataflow, and then Dataflow will perform transformation, and then it will be returned to BigQuery, right? So it will take some time. So till that time we'll have to wait, and we'll try to explore some other things. If you see here, job is still running. Worker, it says starting one worker in Asia South A region. Workers have started successfully. Right. Let us go to the, if you see, this job is in running state, right? So light green means it's still running, right? So in case of streaming, it will be running forever. Okay. If you see the right side panel, job information, okay, job name, job ID, SDK version, number of workers are being used, since how much time it is running. This is the hardware related information, right? And you can see the pipeline option here, the runner, right? Staging location, temp location, everything. So our expected outcome is this. If you see the code, right, here we are trying to write our data into BigQuery. This is our data set. Sorry, this is our data set. This is our table. So right now this table is not available in the BigQuery. So once this started writing the messages into BigQuery, then it will create the table and start writing messages into that table. Okay. Right now I don't see that table is created. We'll have to wait. Right. So it's still running. Okay, let us go to the job. Still running. Here it will says, sorry, it says, if you see, right, once the messages are being written into BigQuery, here there will be one kind of information displayed, right? Streaming data kind of thing. We'll see that soon. We'll have to wait till that time. Okay. And also meanwhile, right, so see, if you see, right, total streaming data, earlier this is not there. Now you can see total streaming data processed 16 kilobyte, right? So now, as per my expectation, this table must have created in our BigQuery dataset. This is the dataset. Then messages started coming into the BigQuery. Okay, let us see. Let us refresh this page. See, this table is created. So click on this table, then preview this table. right now you can see 2 messages have arrived, right? So it's keep on appending messages. Since it's a streaming job, we'll keep on appending this data to the BigQuery table, right? So let us go to the right Dataflow console, and there are some few other important things I would like to discuss. Here there is a section called logs, right? So you can also see the logs, the job logs, right, pertaining to this job, right? Over here, if there are any error, there are any information, everything will be displayed here, and it is immediately available. It will be available till that job is running, right? So you see that worker configuration, what kind of worker, N1 standard 2, and which region, okay, how many workers are spinned up and running. If there are any error, clearly it will be available here. Based on that, you can debug your pipeline and you can fix that issue, right? Here clearly you can see total streaming data processed 81.45, right? So let us go to the PubSub topic as well. We'll see. This is our topic, right? This is where the cloud scheduler is sending its messages, right? You can see the data, right? Here there are some interactive dashboards available in PubSub console. You can see data is coming up, right? Let us go to the BigQuery and refresh once again. Let us preview now. Now you can see 3 messages have been added, right? Like that it will add messages at every 2 minutes window. So messages are receiving every 1 minute interval. It group those 2 messages based on the 2 minute interval. It will append that. Okay. All right. Let us go to the data flow. Now I will try to stop this job, right? So because since it's a streaming data, it will be running forever. In order to stop it, I have to click on the stop button. Here you can see 2 important options. One is cancel and one is drain. So cancel, usually it's not a best or better practice to go for this option. If you go for this option, that cancel, so job will be immediately cancelled abruptly, and by the time any pending job or pending data to be processed, it will be come out abruptly. It won't process that pending data. But in case of drain, right, it's a soft exit, right? So what it will do, right, it will process the pending data, then it will come out from the job. So usually it is a standard and good practice to go for drain in case of streaming data processing. Okay, so I'm selecting this option and I just click stop job, right? Okay, let us go back to the job window. You can see it's training. It will take some time, right? So because, right, it has to process the pending data, right? Okay, let us go to the BigQuery window once again. Let us see if some more messages. See how many messages have been. There are 6 messages have been added. Okay, this is how we can process streaming data using Dataflow. Okay, so if I hope you understand. I hope you understand the entire process. If you have any questions, you can always come back to me. Thank you.